Welcome, I'm Nate Smith. This is the third hour of practice I'm putting in of 100 hours of practicing refactoring. Today, like the previous 2 hours, I'm going to be focusing on a problem called the Gilded rows. I'm going to be doing the refactoring in a programming language, or in Ruby. And yeah, let's get after it right away today. So in the last practice session, we were able to get 100% test coverage and some refactoring of some of the nested conditionals and lifting those nested conditionals out. Today I want to make sure that I do a really good job of the mechanics of that and hopefully get that done quickly enough that I can do some more refactoring to extract out some of the item logic, and we'll see a little bit more what that means as I get into it. First, we just want to get started. We'll make a project directory here. Maybe up 3 levels. Okay, so we have the spec and the Gilded rows here, but the other thing that we're going to want is our project setup files from the last. So that's our shell.nix and our dirm config file. Dirm is going to be a little noisy here for a minute. We can type dirm allow though. And we should, let me just make sure we clear the path cache here. And there are some other things that I'd like to make sure. So bundle config this Nokogiri stuff. And gem install bundler. Make sure we have a decent version of bundler on the system. So this is just getting project set up. We should be able to run. Good. Okay, actually it's important that we don't have our spec installed. If we did have our spec installed, it would be installed into the local directory because I isolate my project environments with Nix. I just want to make sure that we get a failing test here. Okay, so I'm going to say that we're good to go here. Just this line ending stuff drives me crazy. Set, is there like a show hidden? No. Okay, actually don't know that setting in Vim. Let's check out a branch for the third practice session and commit setup. Okay, so we have the basic files from Emily Bach's Gilded Rows project on GitHub. Now we just want to do some basic sanity stuff. I actually forgot. Let's put 55 minutes. We've probably been at this for 5 minutes. Just to keep us honest about putting in an hour of focused practice. We're going to need a gem file to get IntelliJ to understand the project, I believe. Usually we want rspec rake, and I think that's really all we want. We don't even we don't technically need rake, but yeah, so we're good there. Let's pop open IntelliJ and import this project. So actually, you know what? I want a better layout than this. So let's make lib inspect directories. Let's move gilded rows into lib, and let's move gilded rows as spec into the spec directory. And let's run our spec. Okay, so we get a load error, which is makes sense because this was a hard-coded path. We're just going to do require relative here, and try that. All right, so we get back to a failing test. That's good. Project layout, we'll call that commit, and now we can import it. So we want to import now this is where we got screwed up the last time. Actually, we'll probably be okay here. So if we do 003 gilded rows, it should find our sources. And the project SDK, the thing that we do want to change here is this. We probably want to change that. And I think this will be the shortest project setup portion of a practice session that we've had so far. So I actually don't want it to add those. Okay. And just get it to bundle. Install those gems. Okay. Okay. I'm just gonna shortcut this and do the cache invalidation. This worked last time to make things in IntelliJ sane. I just want to speed this up as much as possible. I know this is a real drag to watch. It doesn't make for very entertaining stuff, but I want to get good enough at it that I'm quick, and at that point maybe I'll start the video with the project fully set up and focus instead on the refactoring. But it's important to go through these motions and smooth out the rough edges, right? So that's what I'm doing here. Okay, let's bust open. I don't necessarily really care about the project right now. Let's get the spec open. And it's possible that, huh. Oh, wow. Let's see how we do. I don't really have a good mental model of how IntelliJ introspects the Ruby dependencies. And so I feel like I'm crazy when I see all these errors. Okay, so let's add Rubocop just to satisfy and install. get our spec. I think when this little indexing action, oh, we can't see it because my face is over it, but there's a little progress bar here. And so when that's finished, we should get the getter buttons for running the spec. Yeah, I think what I'll do in preparation for the next one is I'm just gonna have all of this kind of project setup portion done well beforehand, and that should really help with just the flow of this video. Well, that was unexpected. I think we also need simple code. I suppose that would make sense. That simple code would need to be there for us to all right. Okay, so I think we're pretty much good. We're gonna move this to the bottom right. It provides project level statistics that I don't care about. We are gonna use test coverage to guide us through some of the refactorings, just to basically help us remove dead code once we have full test coverage. Let's commit. All right, let's do some stylistic stuff to begin. So one of the things I want all my specs to take 4-phase test structure. So the 4 phases are setup, exercise, assert, teardown, and pretty much any test can abide by that layout. And I just use blank lines to delimit that, to delimit each phase. So we're gonna keep auto test on just so that, and let's get this test green. Okay, so now we're green. Let's commit. Okay, so we have one unit test that's totally useless in that it doesn't, well, it's not useless. It does test that it doesn't change the name. I don't really want to, let's take a look at the code. You can see this is like a big gnarly mess of nested conditionals. I don't want to have to understand this code in order to refactor it. I want to be able to refactor it in order to understand it. And in order to refactor any piece of code, you need to have confidence that you've got enough test coverage in place that if you break something or you unintentionally change the behavior in any way, you'll have a test failure that reflects that. The best way that I know how to do that with code that you're unfamiliar with is with this tool called approvals. And so we're gonna add the Ruby version of approvals to the gem spec, and I will show how that works. also want to open up the I don't know why we're searching through. Okay. So spec. Huh. I don't know why we're searching through all files. Maybe open files. I don't know. One thing we're gonna want to set up approvals with is a spec helper. It's usually what you include at the top of every RSpec. And the other thing that we're gonna do in order to remove some of the boilerplate is let's just put the Gilded rows require inside the spec helper. That way in our spec we can just only require the spec helper and then everything will be taken care of. We should now be able to go back to running this spec with coverage and getting green. Okay, so let's call it install approvals. And we're going to describe, oh, actually we already have a description. And we will say that update quality is characterized. I use that phrase because Michael Feathers calls tests that cover, or these kinds of tests that cover legacy code characterization tests, and they're to capture the existing behavior. So we're going to use a tool that approvals provides, which is this verify block, and basically the return value of this block is going to be serialized and saved to a file, and then anytime that the return value is changed in some way, approvals will show you a diff of those changes, and then you can accept those changes or not. So the idea is we're going to try to get every possible return value from this code, or every possible output from the existing code into this file, and then approvals will just make sure that whenever we change a piece of code, it'll run all of the inputs and compare against all of the outputs, and it'll just be a really safe harness. I'm kind of hand wavy on that, but I'll show you how that works. So the output of this, we can see that update qualities, the method output itself isn't very interesting, but we do know just by looking at this code that what it is doing is modifying the items itself. So you can see here, like, it mutates item quality. So at the end of the day, what we want to know is that the items themselves aren't modified. Or sorry, what we want to approve is the value of the items once we've mutated them. And so how do we mutate? It looks like what we do is pass in items and call the update quality method. And what are our items? Our items are going to be something dot map so it's going to be some collection of inputs that we have to map into these item objects. So we have name, sell-in, and quality. So it'd probably be good for us to have name, sell-in, and quality passed into the block, and then just do item.new name, sell-in, quality. And just make it easier on the eyes here. Okay, so now we have to figure out what we're going to map into that. In order for us to hit every possible branch, we probably need to have an idea of what every possible input is. And it looks like items can have a name. Since items have name, quality, and sell-in, we want to make sure that we have every interesting name, every interesting quality, and every interesting sell-in. For the interesting names, that's actually not too difficult to do. Let's say we have names. We're going to make a names array here. Age Bree is a name. Let's just start with, we'll go back and fill in all the interesting names. But let's get this all wired up, and then we can add in the other interesting values. So there's these sell-ins. These sell-ins can be 0. We can just use the values from the first test there to start, and then qualities is going to be, we can start with 0. Let's also, okay, so now we have the three kinds, the three collections of interesting inputs, and we need to combine those so that they give us all possible inputs into this update quality method. And the way we can do that is by using a method in Ruby on the array object called product. And this gives you the Cartesian product of the original array combined with whatever the argument arrays are. So in this case, we can do sell-ins and qualities. And this will give us every possible combination of name, sell-in, and qualities from these arrays. And so now we are in a spot where I think we can run this. Right. And so we get an error from approvals here. And let me just pop over to terminal. Approvals comes with this verify, or with a CLI. And the CLI will pop open a diff between these two files. So there's an approved and a received. The received file is the output from the current run of the tests, and the approved file is the output, is the last output that we've approved. Since we haven't approved anything right now, this file is empty and we are just seeing the new output. So we can see here we get like a pretty simple, looks like inspect of the raw Ruby object. Since we want to be able to compare outputs across test runs, these object IDs are going to get pretty gnarly. So we want to have a more stable serialization of this item. And the way we're going to do that is, I happen to know from previous times doing this that there is a 2s on the item object. So if I'm surprised that this is not just running. It should be. We are going to get another approval error. and we're going to run this approvals verify. Okay, and so we can see this to string of the approval, or of the item object, and this is going to be stable across test runs. So this is what we want to use as our approval format. That is good enough to commit, I think. Let's make sure that we get, I don't know what this .approvals file does, but first approval. But now we are in business. So now what we need to do is, we can see we've got code coverage turned on. Let's run this and watch it pass. And we've got code coverage turned on, but we can see that we've got red here. And this red is going to be very problematic if we start refactoring, because it means that that code isn't covered. And so if we change any behavior, we could end up breaking something in the existing code. So let me start adding interesting inputs in here. I'm very not happy that that this isn't running anymore. So let me back that out and make sure that the auto run is actually happening. Okay, so now it looks like it's good. So I don't want to pay attention to the test failures so much as I want to pay attention to the red here. So there's still red. We added backstage passes in, but we should also add in sulfurous. So we're just going to copy paste that in there. And we can see that we're still red, but it's because the item quality has to be greater than 0 there. So what I like to do is get every input around numbers like that, numbers that you're switching on. And we can see that we want to be not HBRE, not backstage passes, and not sulfurous, but we can only be one of those 3 right now for item name. Let's do just totally bogus item name. All right, so now we've hit green there. Let's make sure that we're hitting all the interesting literals is what you can take a look at. So we know that quality can be -1, 0, or 1. There's this 50 here too. So let's do 49, 50, and 51. So that'll hit either side of that conditional really nicely. Sell-ins can be at 11 is a special number there. So let's do 10, 11, 12. Quality at 50, so we're hitting that. Sell-in at 6, so let's put 5, 6, 7. And then we've got quality at 50 already. We have sell-in at 0, but we should cover either side of that. So let's get -1 in there as well. Okay. So we have now all of this is green, which is a good sign that we have all of the coverage, and we've gone through all the conditionals pretty carefully here and made sure that we're hitting either side of at least the numeric ones, and the names of the items we've got captured here too. I think that is probably enough to be confident. that we hit every case. So this is 215 test cases that we've generated there. And approvals is going to take those 215 basically outputs and make sure that we have the right input, and make sure that it keeps getting those same outputs over and over and over again. So we can trust that approvals will tell us if we change any behavior. Okay, let's keep committing from here. So T full coverage, we'll say. And I actually don't care about the test anymore. I can simply focus on improving the code now with safe small changes over and over and over again. We're going to start with just the stylistic stuff. All right, and so with these conditionals, the refactoring that we want to do here is one where we can start peeling out each condition. And we know, I didn't cover what the gilded rose actually is, but at the end of the day, what we want to be able to do is add a new kind of item, a conjured item, and those conjured items degrade twice as quickly as the other items. That isn't going to be relevant for a lot of our refactoring because we're not going to take a look at the behavior of this code. We're going to try to do small mechanical refactorings that rely on safe changes and make lots of those slowly or quickly. So in order to do this effectively, like one of the things we might want to do, or what we're going to want to do, is focus on just the item logic. So we can see that I think if we can jump to the end of this block here, yeah, so we can see that update quality iterates over every item and updates each item individually. So one reasonable refactoring here is to extract a method that just updates the item. So what we're going to do is we're going to pop into this block here. We'll go up a couple. And we will run an automated refactoring to extract an update item. So we can see update quality is now in a pretty good spot itself. It goes through each item and updates it. That makes sense. If I were to read this, I wouldn't be unhappy. Now, update item on the other hand, pretty unhappy. Let's commit that refactoring. I'm going to be committing pretty aggressively here. Now, what we do want to do when we lift these conditionals out is we're going to want to pick a conditional, create an if-else on that condition, and then duplicate this method body into each branch of that if-else, and start to prune out. Sorry. And start to prune out the code that's no longer getting run based on that condition. So this will become clear as I do it here. What we need to do first is we can introduce an empty conditional. We know that is going to be a safe change. Let's pick aged brie as our condition. And actually, let's just save that and run. that's essentially a no-op, and so it should be good here. Okay, and let's commit that no-op if, or empty if. And then we want to take the code below it and duplicate it into either side. So the way we're going to do that is we're going to take this, we're going to extract, run an extract method, refactoring on it. Oh, I don't need 1Password yet, or at all. Okay, I'm just gonna run extract method. We don't care what the name of this is, we just need a method. That wasn't what I wanted. Okay. You don't care what its name is. Ugh. My typing ain't so good. Okay, so this should also be safe. We're gonna call this extract method. And then putting it into either of these else statements should be safe. Okay, so our test will pass. We're gonna commit this. Okay, and then finally, what we're gonna do is inline the method. We don't want to keep the method around. The following problems were found. Methods not supported when return statements interrupt the execution flow. Okay, so I think I understand why this happens. And it's because Ruby is an expression-based language. And so depending on like which expression is finally evaluated in this pretty gnarly method, the return value will vary. So what we do know about kind of update quality is that we never use the return value. And so one thing that we can do to make this safe, we do have to make a slight behavior change, but not a meaningful one. And we can see that our tests still pass. We're gonna say return nil. The reason that we're gonna do this is because this now makes it so that no matter what path through that method we take, the return value of it will be nil. And that's probably okay. I might want to change that to self later on just as an API design thing. But for now, that will make the inline method safer. And IntelliJ won't choke on it. All right, so there we go. And say inline. And now we're in a spot where if aged brie is true, then we're executing all the code here, but we can now see which parts of this code are dead in that case. And if aged brie is not true, we can, that's on the else side of this. So let's see if we can find that again. So on the else side of this, if aged brie isn't, if the item is not named aged brie, we can see the dead parts here. It looks like there's just one dead part here. So we can start deleting this code, we can see this is never run in this case. So delete dead. And we can see the same is true here. We don't want to get too eager here. We just want to delete this one statement. See the test pass, and we will and then we can see this is dead, which means this is dead. This is an MTF, and that means that, okay, we can commit that. And we can delete this statement here, because it's all red. And if there's any other red, okay, so we can delete this. All right, so we've now isolated all of the logic that executes when the item name is aged brie. We can do a little bit to simplify this. So if item name is not aged brie, so this is always false. We know that from here, and then false and is always false. And so this side never executes, which means that this side always executes, which means that we can simplify the condition there. Let's commit that and simplify if is what we'll call it. If item name is equal to aged brie and item name is always not equal, so we can, that's going to be if true, which means this always runs, and so we can simplify that if. If item name equals aged brie, if item name, so this is always false, which means that this always runs, which means that that can replace that. So we've now covered just what or the only logic that runs when the item is aged brie. And this is the kind of thing that we're going to try to do for every single item here. I don't know that I'm going to get far enough to do much more refactoring than that, but I'm getting more and more confident with this particular refactoring. So hopefully we can get even farther next time. So let's peel out another else if. So we have else if item equals, let's make it backstage passes. Actually, in order to do this, we're going to want to extract this method first. So let me make sure. Yeah. So we're going to extract this method. And this is just going to make it easy to duplicate the else statement, like we did before when adding this new condition. So we'll say we want both these lines, and we want the condition to be item.name equals, and it's backstage passes. So all right, so we're green. We're going to call this lift condition, and then we can do what we did last time, which was inline this. Hopefully it doesn't complain this time. And our tests are green, so we can go back to deleting code again. So this is not working, or not running in this condition, so we can delete dead, and this is not running, so we can delete dead, and none of that runs there. So we can delete dead, and you can see how our tests give us tons of confidence here that we're not breaking anything. So we've now deleted all the dead code, but we can go through and simplify the conditionals. So if the item name equals backstage passes, then we know that it doesn't equal HPRE, so that's true. And item name doesn't equal backstage passes, that's false. So if true and false, so we know that this is always running on this side, and we can simplify that conditional. And then we have here, if item name equals backstage pass, so we know that's true. So we know that all of this runs all the time. So we can simplify that if the item name equals backstage passes, we know it doesn't equal that, so we know that that is always true. If item name doesn't equal 3, we know that's true, so we can lift that up. And if item name doesn't equal backstage passes, so we know that that is always false, so we know that this is always running, and put that in there. So we'll call this simplify if. And now we've got all the logic for when backstage passes runs. And we can see that there is no mention of the item name in it too, so this is just relying on the quality, we know that the item name only affects the quality and the sell-in just by looking at the code. We don't need to know anything about the kind of business process that it's modeling. All right, so we've got no dead code. We've simplified the conditionals on this side. Now we can do the same thing again. So we're just going to keep on extracting methods and inlining them and duplicating them until we get, oh, sorry, I'm jumping around a little too quickly here. We're going to do sulfurous this time. Surprise the test pass. Okay, so we've extracted that commit message is a little misleading, but We'll leave it for now. We're going to inline that. And we're going to start deleting dead code. So we know that this is dead, and we don't need that, and we don't need that, and we don't need that. We know this is dead, and we don't need that. And we know that this is dead, which means 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 this is dead. So we've deleted all the dead code there. Looks like we don't do anything with sulfurous. We've got 8 minutes left, which might be enough time. But we've now we've run out of items here. So so it's not super clear where to go refactoring wise, but one thing we can do is we have an idea of what the item names are, so we can start thinking through based on the item names what these conditionals will be in the kind of fall through case of this little huge conditional. So we know the item name is not aged brie is always going to be true in this case, because that's captured in a previous condition, and item name not equal to backstage passes is also going to be true. So we know that this is always going to be true, which means that we can simplify that up there. So let's call this simplify if. And then if item name is not sulfurous, so we know that's true because if it was, we'd hit this conditional. If item name is not sulfurous, we know that is true. We know that this is good. So we're just going to keep on keeping on here. If item name is not HB, we know that's true. If item name is not backstage passes, we know that's true. If item name is not sulfurous, we know that's true. So we can go that. Oh. Oh. That can replace that, can replace that. So we looked at all of that up. And now we've completely simplified the fall through case. And now we're getting into a spot where we have more of the essential logic here. So this is what the HBRE stuff looks like. This is what the else case looks like. We've got item name. It looks like if it's sulfurous, we're not going to do anything. And backstage passes has a little bit more logic in it than the HBRE case. What's interesting here is whether or not, or what's interesting to notice is where the branches are similar. And I think the thing that's interesting is that this code, at least when you squint, looks very similar to the code in this branch. I'm just going to pause for 1 second. We've got 5 minutes. I'll be right back. Okay, so I'm back. Let's give ourselves the 4 minutes that we're going to need to get this done. So where we left off is I was saying it's interesting to check out the similarities in the code now that we've got the essential logic of updating an item. Hopefully, like when you squint, it looks like the HBRE branch looks like the else branch. And I want to see if I can make that a little bit more obvious. So it's difficult without enough vertical space here. Actually, let's just hide this stuff for now. We can actually swap. So let's swap. I don't know. Let me see if I can. Okay, so that was we're gonna move the condition. I mean, we duplicated this two sides, so let's make sure everything runs okay. We're good. Now that I have this else if here, it means I can move it here. And that will get us closer to seeing what we have. So we can see that there is this like greater than or less than 50 that separates the aged brie from the fallback. That's too bad because otherwise the code looks very similar. So it's this quality threshold that seems to be the difference maker here. Saying less than 50 is the same as saying, okay, so actually let's do a small thing that makes these more similar. Let's put those to the top. And we're going to call that flock. And this comes from, that terminology comes from Sandy Metz and Katrina Owens' flocking rules. And it's kind of like a play on birds of a feather flock together, I think. But the idea is you take two pieces of code that look similar but different, and then you make a tiny change to make them look more the same. And we want to get there until the code is identical, or the code can be made to look identical. And I'm totally butchering how to explain that, but we can see that there's this delta here. So we have the quality changes by +1 or -1 depending on the quality here. I don't know that there's much to pull on, and we've run out of time. So that's too bad. We got a little bit further, or I got a little bit further than I did the last time, the last practice session. That's always the goal. If the yeah, that is always the goal, and so that's kind of what I'd like to get to at least this point and start pulling out some of this duplicated logic in these 4 branches, and hopefully we can end up in a place where we can actually get to the end of this kata and have convincing, well factored gilded rows. The reason I've chosen Ruby is because it's a language that's most familiar to me, and maybe with the exception of Clojure, and it's a little less weird than Clojure for anybody who's watching this, and It also happens to be difficult to refactor with, just because name resolution in Ruby is not not easy to statically analyze and things like that. So, but anyway, thank you for watching. If you've made it this far, that's very impressive. And I will see you at the next session.